This is some not on just general idea. Read the question. This is something inclined projectile. I just brought it so that a student must have, this should be inclined projectile. The idea of inclined projectile, nothing new. Go back to inclined projectile and the jet will come out here. I'll draw the diagram, related diagram. Okay, this is the this everything here liquid is filled up. I'll shade it later on. This is setup. So now the liquid will emerge out and should strike normally. This is a jet. So here the liquid will emerge out with a speed v1. This is a height 10 meter. At height x from the bottom, a small hole is made as shown in figure so that the stream coming out from hole strike the inclined plane normally. It will strike here normally. There's a basic condition. This is a jet. I think we have discussed this problem. Ball thrown horizontally such that it should strike the inclined plane normally. Then what is the height? That one, instead of that ball, here we have a jet. That's all, nothing to do. The same concepts, everything will be there. So what we should do, we are going to resolve G parallel, G perpendicular. This will be 30 degrees. G parallel will be G by root 2. G perpendicular will be, let me add up these things. G by 2. G perpendicular will be G root 3 by 2. We'll resolve the velocity vector also. So this will be parallel. This will be the perpendicular to incline. If this is 30 degrees, this is 30 degrees, this should be 30 degrees. I think the basic concept. No? And then by the time it moves from point A to point B, tell me what happened to horizontal component of the jet should become zero, no? Because it strikes normally on the inclined plane. Then horizontal component should become zero. So along the incline, initial velocity v1 cos 30 degrees minus G parallel into time. Why zero? Because what is the velocity of the jet along the incline will be zero when it's striking it. It strikes normally. So that component will become zero. So V1 cos this one. So now what is V1? I think directly shall we write 2G H minus X. From where this is brought? Velocity of Flex. Because at what depth the hole is? At a depth H minus X. Substitute that here, 0 is equal to root of 2G H minus X. Cos 30 will be root 3 by 2. Outside it will be there, root 3 by 2 minus G parallel will be G by 2 into T. So therefore, what we can write is root 3 by check it now. should be equal to, okay, G also will come into picture, no? So 3 keep this equation 1. I adjusted things here. After that, what is the other thing we should, so we have to calculate X, that's all, no? We have to calculate X. What all we know H, and the T is unknown thing. How to eliminate the T? Okay, I'll go for the next, the distance AC. AC will become like a range. AC will become like a range. So what is AC should be equal to? AC should be equal to V1 sine 30 T plus G perpendicular T square by 2. We don't know AC. AC can we bring from triangle cos 30 equal to AC by X. So what is AC? X cos 30. So X root 3 by 2. Substitute here X root 3 by 2. V1 is how much? We know root of 2G H minus X. This is 1 by 2 T plus G perpendicular G root 3 by 2 T square. So this is the equation 2. Substitute 1 into eliminate T, solve for X, you'll get the required answer. What is the problem? I think time of flight, T is equal to this much, no? Here.
Sir, T will be 6 by G H minus X.
Oh, 6 by G, no? Here one. Yeah, okay, this one, huh? 6 by G H minus X. Yeah, 2 will get cancelled, no? No, substitute, put 1 into solve for X, you'll get the required answer. Do calculation later on. I'll go for the next problem. Okay.